I will be discussing the problem house robber 2. The problem statement says you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. All houses at this place are arranged in a circle. That means the first house is the neighbor of the last one. Meanwhile, adjacent houses have a security system connected and it will automatically contact the police if two adjacent houses were broken on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So as the problem says that all the houses are arranged in a circle, this means the first and the last element are next to each other. The solution works by realizing that in a circular arrangement, we cannot rob the first and the last house together. So the problem splits into two linear house robber 1 cases. The helper function modifies the input list to store the maximum money that can be robbed up to each index using the formula dp of I is equal to max of dp of I minus 1, comma nums of I plus dp of I minus 2. Which means at each house you decide whether to rob it and the two best houses before or skip it, taking the best up to the previous house. In the main function, the algorithm computes this dp twice, once excluding the first house and once excluding the last house, then returns the maximum of the two results. This guarantees that no illegal adjacency first last occurs while still maximizing total robbery. The second approach to this problem is the solution code handles the circular constraint by splitting that robbery plan into two linear scenarios: rob houses 1 to n minus 1 or rob houses 0 to n minus 2. The helper function implements the class house robber dp in big O of 1 space using the two rolling variables house 1 and house 2 to track the best loot amounts and without robbing the current house. For each house, it decides whether to rob it, adding its value to the best from the two steps back, or skip it, taking the best from the previous step. Running this logic twice on both the scenarios on returning the maximum gives the optimal amount without triggering security alarms. And the pattern which I have observed while solving this problem, circular to linear DP. The patterns are maximum sum circular subarray, gas station burst balloons, delete and on, maximum product subarray. 7th is climbing stairs in a circle. 8th is minimum cost to paint houses. 9th is necklace cutting problem, and 10th is circular appointing scheduling DP, which is a DP variant.